Hello. So we've talked about some stuff about polynomials. We've started polynomials. We talked about adding or combining like terms, combining polynomials. Today we're going to look at multiplying polynomials. And the multiplying is based on something we already know. That is based on the product rule or product shortcut of working with exponents. Remember, we talked about when you are multiplying with the same base, you add your exponents. And if those two bases have coefficients, okay, this is all straight multiplication. 2 times x squared times 4 times x cubed. And so because it's straight multiplication, that allows me to multiply my numbers and that my coefficients, and then use my rule of exponents, the product rule, to multiply those bases. So we're going to get 2 times 4. And x cubed times x squared times x cubed, x to the 5th. So we are familiar already with the idea behind multiplying. So if we have a single term times a single term, for example, negative 5x to the 5th times 2x cubed. Remember, what separates terms if there's a plus or minus between them? Okay, so this is a negative 5 times 2. And x to the 5th times x to the 3rd is x to the 8th. Good. Okay, so multiplying single terms is pretty straightforward. We already are familiar with that. We're going to take that idea and expand it a little bit. For example, what kind of a problem is this? Again, we're familiar with this sort of thing. This is a distribute problem because there's an addition in the middle. All right, so we're going to distribute 3x to 4x or multiply 3x times 4x and 3x times 5. And these two terms, separated by this addition, are not like terms, and so we cannot add them together or combine them. So that is as good as it gets. All right. What is the next step? Multiplying a binomial times a binomial. And again, you have probably heard this before. You may remember, how do we multiply two binomials? What process do we use? We give it a short nickname, right? It's called FOIL. And what does FOIL stand for? First, outer, inner, last. What do I even mean by first? First what? First term in each binomial, that's the first thing we're going to multiply. So the first term in these two binomials is x and x. So we're going to multiply x times x, which we already know is x squared. Then we look at the O, outer. What do I mean by outer? What's on the outside of these two binomials? X times 2. Inner. What happens? What's the inner? The inner terms, the inside ones. 5 times x. And what are the last terms in each binomial? 5 times 2. And what I hope you notice is that these middle terms quite often will be like terms and we will combine them or add them together. Remember, when we're combining, what do? We add or subtract our coefficients. We do not do anything with exponents. So 2x plus 5x is just 7x. Okay. Almost always, when we multiply a binomial times a binomial, we're going to get a trinomial. All right, let's look at another one. So here we go. We have a binomial times a binomial. We're going to multiply first term times first term. X times 2x. 2x squared. Now the outer terms, negative 5 times x. What are the inner terms? That's 3 times 2x. And what is last in each binomial? 3 times negative 5. Watch your signs, right? Okay. Now we look at these middle terms. They are like terms, and we're going to combine them or put them together. What are we combining? Negative 5x plus 6x. Negative 5 plus 6 is 1. I wrote that 1 just so you know, but typically if a variable has a coefficient of 1, we don't usually write it, okay? All right, so FOIL is a process we use. It's the name of the process to help us get through multiplying two binomials. And again, typically speaking, when we multiply two binomials together, we usually get 3 terms. Now, I'll just show you, just for the heck of it. How about these two binomials? Let's go ahead and FOIL them. X squared times x. Outer terms, here we go. X squared times negative 4. Inner 3 times x. And last, positive times a negative, which is negative. Now when you look at this result, this is the product, by the way, right? Because this is what we got when we multiplied something. When you look at this product, what do you see? There are no like terms. How come? Well, look at my middle terms. They're not like terms. Remember, we cannot combine a squared term with an x to the first. They're not like terms. Okay? How come? How did this happen? Look at your problem. What's different about this one is that these were not like terms. And so, when I did my outer and my inner, I didn't have the same exponents, right? So that's how come I have 4 terms instead of the typical 3. When your binomials, when those variables have the same exponent, that will produce like terms in the middle. But if your exponents are different, then you're not going to get 3 terms. All right. FOIL, I think, is something I'm hoping that you remember. Let's look at a little bigger problem. How is this different? This is a binomial times a trinomial. Okay. Now, there's a couple ways to set this. This is not a FOIL. All right, FOIL is only what? Binomial times a binomial. So there's a couple ways to set this up. Here's how I prefer to do it. I think of this like a double distribute. In other words, I have to distribute this first term or multiply this first term times everything in here. And then I have to come back and take this term and multiply it by everything in there. And then I'm going to combine my like terms. So this is how I set it up. I'm going to multiply x times all of these terms. Here we go. X times x squared. X times 3x. And x times -7. That's the first stage. Now we get to the second part. I'm going to distribute this 2 to everything in the parentheses. But watch what I do with it. 2 times x squared is 2x squared. It's going to help me to know which terms I can combine. I'm going to put it right underneath the other x squared term. One more time. 2 times x squared is a positive 2x squared. I just line them up so that it helps me to know which ones to combine. Okay, 2 times 3x. Positive 6x. And notice how I put that in my x column. And then 2 times -7. So that when I combine all the like terms, I can get my final answer in nice descending order. I don't have to worry about losing a term. They're all lined up and ready to go. So here I go. X to the third, 3 plus 2, -7 plus 6 is -1x. And then I'm just going to carry down that -14 because there's no other number to combine it with. Okay, so 2, 3, 4 terms out of this, all right? Just take a look at the process one more time. Because this is a binomial times a trinomial, I can't fall back on the FOIL process. So I have to distribute this first term, multiplying it by everything in this trinomial. And that's where this first line came from. X times x squared, that's where the x cubed came from. Then I have to come back and distribute this 2 to everything in here. And that is where this line comes from. And as I'm distributing this 2, I put it in, because that's 2x squared, I put it under the other x squared term. And that makes my life easier when I'm going to combine them. Recall that combining them, adding them, or subtracting them, we add or subtract coefficients. We do not add our exponents. When do we add exponents? That's the multiplication stage, okay? All right, multiplying polynomials. Step by step, it's one term at a time, okay? All right, remember your product rule. When you're multiplying, add exponents. Remember your combining or adding rule. Add or subtract coefficients, nothing with exponents. Thank you.